Hello guys, in this session I'll be going to cover one of the most important feature of JDK 1.8, that is functional interfaces. So let's start it. Basically this is the feature of JDK Java 1.8. Okay. So let's talk about it. What is functional interfaces here? So what is functional interfaces? Functional, and what are the uses of functional interface? Okay. And what is the intention behind developing of this feature coming as a part of JDK 1.8? So let's talk about it. A functional interface is nothing but an interface or any interface. Okay, any interface contains or any interface having only single abstract method. That interface is nothing but functional interface. Okay, so what is the definition here? Any interface which is having only single abstract method. So how to remember that? Only single abstract method. Okay, yes I am Sam. So then if you can convert it into the full form of single abstract method. Okay, so basically if any interface if any interface contains the single abstract method, that interface is nothing but a functional interface. Then let's talk about some predefined interfaces, so which is already there in our Java. So what are those? So we have runnable interface. Okay, so which has only one abstract method, that is run. We have callable. Okay, so that callable interface having only one abstract method, that is called. Okay, we have comparator, comparable. So these are the all interfaces we have already. Those are functional interfaces. Okay, those are what? Those are functional interfaces. Now let's talk about the what is use of functional interface. Okay, use of functional interface. Now we see what is functional interface. A interface which has a single abstract method. That interface is nothing but a functional interface. Now let's talk about the what is use of this functional interface. You see, in the last session I discussed about the lambda expression. Okay, about lambda expression. What we see in last session, that means previous session, we see about the lambda expression. So as a part of this lambda expression, what we covered? We covered how to write the lambda expression, then what are the rules we have to follow while writing the lambda expression. Then apart from that, we discussed some example as well. Okay, so these all things we covered, but we didn't cover how to call, like how to call the lambda expression, like how to call the lambda expression. Okay, we didn't cover this question. So by using functional interfaces, okay, the answer is by using functional interfaces we can call lambda expression, or we can invoke lambda expression. Okay, so this is the answer of this question, like how to call the lambda expression. The lambda expression can be called by using the functional interfaces. So main intention or main use of a functional interface is to call the lambda expression. Okay, so now let's talk about how to how to create our own lambda, how to create our own functional interface. Okay, like how to create our own functional interface. Okay, so what is the criteria while declaring the functional interface? So it should contain the single abstract method, and it must contain the single abstract method. Okay, so that is the only one criteria we have to follow while declaring the functional interface. Let's declare the one interface here, what it is. So I'll be going to declare one functional interface, so like this. So using the function interface keyword. Okay, now I am going to write one test method inside it, so that is abstract. So now I have declared one functional interface which contains the one single abstract method. Okay, one single abstract method. So that means this test interface is a our functional interface. Okay, now let's see here. Suppose I replicate this method, I'm going to add another one abstract method inside it, and that is test. Now tell me whether it is functional interfaces. No, it is not functional interface. It is not comes under the criteria of functional interface. So what criteria set? That criteria set like any interface contains the single abstract method. That interface is nothing but a functional interface. Okay, so like we directly added this abstract method here. So now this is not a functional interface. Then how to restrict? Okay, how to restrict that interface to add only single abstract method? Okay, how to restrict? So to restrict to the to restrict the interface to add a single abstract method, we have one annotation, that is at the rate. Okay, that is at the rate functional interface. Okay, so basically this annotation, when we use on top of any interface, then that interface can, okay, that interface can contains or should contain a single abstract method. Okay, if we try to take abstract method, okay, if we try to take abstract method inside that interface, then it will return the exception. Okay, but apart from that, when we annotate it, so there is only restriction for the abstract method. Okay, but we can add the static method, any number of static method. We can add the default method. Okay, any number of default method. Okay, we can add any number of. Okay, we can add the static and default method. Okay. So this rule is not for static and default, but this rule, when we annotate this at the rate functional interface, so strictly speaking, that interface should be contains the single abstract method. Okay, if we try to add the another abstract method, then we will get an definitely we will get an exception. So to avoid this, so let's to avoid this kind of scenario, like this, to user by default, if user adds the another uh, abstract method, then something will get impacted. To avoid this kind of problem, so we have to annotate that strictly speaking, that test interface is a functional interface. Don't add anything extra inside it. Okay, to give something interaction to the test interface, then we have to annotate that test interface with the at the rate functional interface. Okay, suppose let me go to the let's go to the IntelliJ and check how this functional interface works. Okay, so this is my I have created already one class here. Let me create the one interface here, and let's make that interface as a functional interface. Okay, so this is my interface, and I'll be going to write one abstract method. So that is test. Okay. Now, if you can see, this is a functional interface. Okay, but there is no restriction to add one or more. So I can add another abstract method as well. Okay, something like this. But I don't want to do like this, because if someone going to change like this, then somewhere like some coding will get impacted. Okay, something will happen. Okay, because of this change. So there may be a chance to down our application as well. Okay, because we are going to use lambda expression to call. We are going to use this interface to call the like lambda expression. In that case, there may be a chance to get the ambiguity. Okay, to avoid this kind of problems, so we have to annotate this with address functional interface. So now see, when we add the address functional interface, it started throwing the compile time action. What it is saying? Multiple non-overriding abstract method found in the interface lambda dot is. That means what it is saying? Multiple abstract method is found. Suppose I combine this method. Now see, the compile time exception is gone. Correct. So what is the rule here? Strictly speaking, when we annotate any, like when we annotate this functional interface annotation on top of any interface, then this is the like this interface should or must contain the single abstract. If we try to take abstract method, another abstract method, then we will get an exception, that is compile time exception. Okay, so that is the way we can use the functional interfaces. Okay, now we are going to see some practical examples like functional interfaces, how works in inheritance. Okay, so let's create one. So let me remove this sub method here, and let me create the one child interface of this test one. Okay, suppose I'm going to interface, I'm going to write one interface that is test child, which extends the test interface. Okay, now if you can see, so I just extend the test interface. Okay, that means so this method will be available here. Okay, that is inherited from parent of interface to child interface. And suppose I make this interface as a functional interface, this will work because we have this functionality, we have this method, void test method inherited here. That's why it allowed. Suppose I am going to add the same method, it will also work because both are same methods. It will consider only one method. Okay, it will not consider the two methods. It will not generate any ambiguity. Suppose instead of adding the same method, if I add some method, so now it started throwing the error. Why? Because it has parent class inherited function, that is test already. Okay, and again we are going to add the sum method, then it won't allow because we annotate that class, child class, with a functional interface. Suppose if I remove that, okay, if I remove that annotation on top of, so now this is started the like the like compilation error will come. Yeah, because why? This is not a functional. Now in that case, this is not comes under the functional interface criteria. Okay, because so this has a test one method and this has a sum method as well. So these two methods will be there. And what is the criteria saying? If that functional interface contains only single abstract method, okay, not contain any or multiple one then more abstract method. It should contain only single abstract method. That interface is nothing but a like functional interface. Okay, so now, so this is a basic criteria or basic example of a functional interface. Now let's talk about the how to call the lambda expression by using the functional interface. Okay, let's see. I'll be going to talk here how to call the lambda expression by using the functional interface here. So now let's create the one interface here. Like I'll be going to create the test here, and inside the test interface, let's add one abstract method which is responsible to do some sum of two operands or to do anything. Like suppose I'll be going to give int a comma int b. So this sum method is responsible to okay. So this sum method is responsible to perform the sum or addition of these two numbers a and b. Okay. Now we are going to use the lambda expression to implement this interface. Okay, we are going to use the lambda expression to implement this sum method. So how we can write this, or how we can write the lambda expression for this sum method? So as I mentioned here, so without return type, without name, without any modifiers, so write our method. So like, so let's write the lambda expression for this method. So here without any name, without any return type, without any modifier, so that method we have to write. Now give the implementation after this array token sign, so we have to use the implementation. Suppose a plus, correct. So this is the lambda expression, correct. Now let's assign the, okay, let's assign the reference of test, because we are going to provide the implementation for the sum. Then let's assign the reference of test t. Okay, so this is our lambda expression. Okay, now this will not work. We have to add this lambda expression inside the executable area. So outside any method block and any constructor, all are unexecuted area. So whatever executable statement will be there, we have to add inside the executable area, that is our methods area. Okay, so if I write here, yeah, system.out.println, so this will not work. Like system.out.println. See, we are, that compiler started throwing the exception because this is not our executable area, cannot resolve the symbol. So we have to, like, we have to use this method inside the method block and constructor. So not, if we try to use this in anywhere, then we will get an exception. See, now if you can see, I directly return this one. So now I don't want to return anything. I just want to, and I'm going to return here. So the bad returns type you can see here. I want to just print the statement here, or instead of curly braces are not required whenever we have only single statement in your. Okay. So now to call this lambda expression, so we require this functional interface reference. Okay, so by using t we can call this lambda expression. So let's see how we can call the lambda expression. Let me pass some values here, 20, and let me execute this code. Okay, if you can see, I have written one interface here. To implement this interface abstract method, I have written lambda expression for that method. And to call this lambda expression, I have used this functional interface reference. Okay, on this functional interface reference, I have called this. Suppose I am going to write another method inside it. Let's see whether it is working or not. Subtract. Okay, cannot apply to lambda parameter. See, so I have written the, what I have written, subtract one more method here. Okay, and I am trying to implement the lambda expression. Now compiler will started throwing the exception. Why? Because in that case we will get the ambiguity. Why we will get the ambiguity? This both are type of, okay, both are type of int. Okay, so that's why we are getting the ambiguity. So like compiler will confuse which one we have to consider, whether we have to consider as a subtract or whether we have to consider the sum. So both are having same parameter, so in that case we will get an compilation exception. So that is our ambiguity. So here like condition method call system, something like this. Okay, so this is the way we can write, or we can call our lambda expression by using the functional interfaces here. Okay, yeah. Now one more thing I want to disclose here. So to overcome this kind of ambiguity related problem, to make this interface as a functional interface. Okay, when we make this interface as a functional interface, then it will started throwing error here. So then user will not add the one more method to this test interface. So if you can see, if I annotate this with at the rate functional interface, then what happens? So this will like this will started throwing the exception to add the only single abstract method. So don't allow, so this will not allow the multiple abstract method here. Okay, so now our program started working fine. So if I execute it, let me see whether it is doing some or not. And I can call multiple time, like I can call something like this. Okay, with the different arguments. Let's see. So we are saying here we are, by using the lambda expression, we are going to write the concise code, then we are going to write some readable code, and we are going to write some code in a like we can achieve the same scenario in a minimum line of code. Okay, instead of writing the 100 line of code, so we are going to write that code into a 10 line, okay, by using the lambda expression. Then how it possible? Let me tell you. Suppose if I want to, suppose in normal scenario, so let's forget about the functional interface. In normal scenario, what I have to do to perform the to add the implementation for this sum method? So what I have to do, I have to create one class, like class test impl. Okay, so that class implements the test interface. Okay, and after that I have to implement the sum method. So inside the sum method I need to write the logic, something like a uh, std out a plus b. So this is the line of code we increased. We have to write here. These are the lines. Now, if you can see here, to call this code, let me remove that. To call this code, what I have to do, I need to create the object of test impl is equal to new test impl. Okay. Now I need to do something like a sum 10 plus 20. Let's call the 30. We will get the same result. But if you can see, line of code will get increased. Why? Because we need to, suppose to give the implementation for this sum method, we have to give the implementation class. Then unnecessary, that implementation class will be there. Then unnecessary, we are going to create the object of that implementation class. And so like object creation is very costly, because it uh, it occupies the some memory here. on your in your JVM. So that's why there may be a chance to have the performance issue. So to avoid this kind of things, so lambda expression is introduced. Okay, so you can achieve this thing within a one line. Like if you can annotate it, so instead of doing this all things to create the implementation class, implement that method, so instead of that you can directly do, you can write the a comma b. Okay, then you can do same thing in a single statement. Okay, and let's assign the reference here, test t. See how much line we reduce the code here. So near about we reduce code 5 to like 6 line here, and we replace that 5 to 6 line code within a like only in one line. Okay, so t dot when I call 10 comma 20, same approach we achieve by using the lambda expression. See, we got the 30 as a result. Correct. So that is the conciseness we got by using the functional interfaces, lambda expressions. So this is all about the functional interfaces, guys. Okay, so what we learn here, we learn about the what is functional interface. Let me write some notes here. Like what is functional interface? Interface. So just remember one word, that is SAM. What is meaning of SAM? That means SAM. What is meaning of SAM? The meaning of SAM is a single abstract method. Any interface, okay, any interface contains the single abstract method. That interface is nothing but a functional interface. Use of functional interface. Functional interface. The use of functional interface is to call the lambda expression. Okay. What is use of functional interface? The main use of functional interface is used to call the lambda expression. The third is like what is at the rate functional interface annotation. Like we can say to avoid the okay to avoid the ambiguity problem. Okay, so we have to strictly speaking that, so that interface whenever, okay, that interface contains single abstract method. Suppose I annotate any interface with the at the rate functional interface annotation, that interface must be contains the single abstract method. If that interface trying to add the multiple abstract method, then in that case we will get the compile time exception. So that is annotation will strictly speak only add, okay, only add single abstract method. Only add single abstract method. Don't add the multiple abstract method. If you try to add the multiple abstract method, then you will get exception. And what is the third point here? So you can add multiple static and default methods. Okay, you can add, there is no rule for static and default methods, so you can add multiple whatever. Suppose if you want to add as per requirement, you can add any number of static and default method here. So these are the concluded point. Then what is the now main question is what is the relation between a or contract between a lambda expression and functional interfaces? What is the contract? We see contract between a dot equal method and code method. Okay, same thing here. What is the contract between a between lambda expression and functional interface. Okay, so let's see what is the contract. So contract is very simple. Lambda expression, okay, sorry, lambda expression is responsible to implement the functional interface abstract method. Okay, lambda expression is responsible to implement functional interface abstract method. Okay, then what is use of functional interface? As we see, functional interfaces are used to call the lambda expression. Interfaces are functional interface used to call abstract, or sorry, used to call the lambda expression. Sorry, that is the main point. Correct. So if you can say what is the contract here? Lambda expression is responsible to call the functional interface. Oh, sorry, a lambda expression is responsible to implement the functional interface abstract method, and functional interface is responsible to call the lambda expression. So that is the vice versa contract between the lambda expression and functional interface. So that is the one of the questions. So mainly this question is asked, guys. So I'll be going to share these notes in description of this video. So yeah, thank you guys. So that's all about the lambda expression, then functional interface. So what is the contract between a lambda and functional interface, then what are the rules we have to follow as a part of while declaring the functional interface, lambda expression. So those all things we covered as a part of this session 1 and session 2. So keep watching these sessions, guys. So you will get master in JDK 1.8 version features. So thank you, guys.